Over problems 27 to 31. This is specifically related to lesson 6-8. And this is the last thing we're covering before we give you your test. And so hopefully this review will kind of help you make sense of these kinds of problems. So this is over difference of squares and also perfect square trinomials. And I'm going to reference the mathematics chart you're going to get for the STAR test. You're given equations for perfect squares and difference of squares. And hopefully you watch this video after the lesson on Thursday, but if not, I'm going to try and explain this the best I can right now to help you understand these problems right now. So I'm going to focus on the perfect square trinomial problems, and then I'll move on to the difference of square problems afterwards. So, by the way, when they say difference of squares and perfect squares, we're talking about numbers that are like perfect squares. Like if I were to have like the square root of 1 is 1, it's a perfect square. The square root of 4 is 2, as another example of a perfect square. Square root of 9 is 3. We have the square root of 16 is 4. Square root of 25 is 5. Like the square root of 36 is 6. So we're talking about what numbers can we take the square root of and get a whole number, basically. And so that's the kind of problems we're dealing with. We're dealing with squares. These are perfect squares. So 1, 4, 9, 16, 25, 36. 49 is another one, 64, 81, and like 100. If you square root those numbers, you get a whole number. And so let's look at 27. It says Mallory thinks that 9x squared minus 12x plus 4 is a perfect square trinomial. Do you agree or disagree? And why? Show your work for 27 and 28. 27 on 28. So we're going to show the work for this problem over here on the right side. So she thinks this is a perfect square. And so I'm going to look at the formula chart. And if you notice here, we have a negative and a positive. And I have an equation that has a negative and a positive. So I'm going to write this equation down on the right side. And we're going to see if we can get this equation here to kind of match this formula here on the right side. And so I'm going to do a squared minus 2ab plus b squared. We're going to see if that equals a minus b squared, basically. So, again, I'm writing this bottom one here because this one here has a negative and a positive in it. We have a negative and a positive. So far, it's looking like Mallory might be right because this equation here kind of matches. Now, the idea here is we need to have a perfect square as not in the first term and the last term. Notice 9 is a perfect square because if I square root it, I get 3. Same thing for 4, it's a perfect square. If I square root 4, I get a 2. And so the idea is I'm going to write down this equation, 9x squared minus 12x plus 4, and I'm going to see if I can get it to match this a squared minus 2ab plus b squared. I really don't care about this portion on the right side. It's mainly I want to see if I can match it up to this left side of the equation. So the idea is, notice here that a squared equals this 9x squared. Like these are equivalent to each other. Notice how we have this negative 2ab is equal to this negative 12x. And then lastly, we have this b squared is equal to this 4. So I'm just grouping the first term matches the first term, second term matches the second term, third term matches the third term. And so what I'm going to do is, if I square root a squared, I can square root the right side as well. Because on an equation, what I do on one side, I can do the other. And the square root of a squared is actually a. That square will cancel out. And then what's the square root of 9? Well, that's 3. You can type that into Desmos. And then the square root of a square here, again, cancels out. And we're left with just 3x. So a is equal to 3x if I square root both sides. I'm going to skip over here because I don't know what b is. But on the right side, if I square root b squared, it just gives me a b. And if I square root 4, it gives me a 2. So notice right now, 4 is a perfect squared, again, because it becomes 2. And now that I know what a and b is, I can substitute a and b here. And if it matches negative 12, then this is a perfect square because it matches this formula here. So I'm going to put negative 2 my A is a 3x, my B is a 2, and let's see if that equals 12x. Now I'm not going to get Desmos up because we can do this in our head. Negative 2 times 3 is negative 6. Negative 6 times 2 is negative 12. And then of these three terms, what terms if you want to say, if we multiply these three values here, notice there's only one x between the three. So I get negative 12x equals negative 12x. So this matches out. When I square rooted my A, I got 3x. When I square rooted my B, I got 2. And when I multiply these together, I got my negative 2AB, or negative 12. And since all of these end up checking out, I can assume that this is a perfect square. So ultimately, and I'm going a little bit beyond here. Let me change colors here. This whole thing on the left side here would simplify down to just 3x minus 2 squared. Because we know what our A is, 3x, we know what our B is 2, and so this 9x squared minus 12x plus 4 will equal 3x minus 2 if I substitute it back in. And I'm going to be okay with this. So I was mainly checking what A was, what this negative 2AB was, and what this B was. And since these all kind of check out, I'm assuming this is the right answer here. So I'm going to say, yes, I agree. And I'm going to say because, what would be the best way of putting this down? I agree because the trinomial, yeah, so because the trinomial factors down to a squared minus 2ab plus b squared equals a minus b squared. And so that's the idea. And if you don't quite understand this, we're going to keep doing a little bit more. And keep in mind, we're going to do another lesson on this on Thursday, hopefully, and go over this in a little bit more detail. So looking at number 31 now, because this is another one that has perfect squares, it says which two trinomials are perfect squares. And so I'm going to keep this one a little bit shorter than what I did in 28. 28, I kind of went a little overboard. On 31, I'm going to look at what perfect squares are on the mathematics chart. And remember, they're equal to this a squared plus 2ab plus b squared equals a plus b squared. They're also equal to a squared minus 2ab plus b squared equals a minus b squared. So notice we have two pluses in here, and we have a minus and a plus on the trinomial. So if I will look over here, I'm going to try and match which one of these has two pluses in here. And it looks like A is one of them because we have a plus and a plus. So we're going to keep our mind on this one. And then I don't see anything else with two pluses. But then we have this other equation which has a minus and then a plus. A minus then a plus, that doesn't match. A minus then a plus, that doesn't match. And a minus and a plus, and this one will match. So ultimately, if we're looking for ones, if we know for sure there's two of them, then we know for sure these are going to be our answers because there's no other options here. But if we want to go a little bit further, what we can do is we can look at the original equations, and I'm going to write them down so I don't have to keep looking back and forth here. And you can write these down if you want to. We have a squared plus 2ab plus b squared equals a plus b squared. And then I have a squared minus 2ab plus b squared equals a minus b squared. And the way I'm solving these problems match this problem, but when it comes to this right side here, this is more for a different kind of problem, and we'll explain that in the lesson. But right now, I only need to know the left side here. I need to know, do we have perfect squares in the front and the back? Do we have perfect squares in the front and the back? That's all I care about on these problems right now. So if I square root the front and the last, first and last term, square root the first and the last term, as long as these are square roots, and then we can check this middle term, we should be in good shape right now. So what number is associated with this x squared? Well, there's a 1 in here, believe it or not. So if I square root 1 x squared, I end up with just 1x. So my a value is 1x. If I square root this 16 here, I end up with a 4, and that's my b value. And I'm looking at this very first equation here, because this is the one that has a plus and a plus. And notice we have an a squared, and we have a b squared. So if I square root this first term, that gives me my a term. And if I square root this last term, that gives me my b term. And I want to know if I were to throw in the 1x and the 4 for the a and the b, does that get me an 8x? And if it does, then this is the right answer here. So I need to know, does 2ab equal 8x? And my a is 1x, so I can say 2 times 1x, and my b is 4. Is all that going to equal 8x? Well, 2 times 1 is 2, 2 times 4 is 8, and then between these three, we have only one x term, so yeah, that checks out. So a is definitely the right answer. And we can do the same thing on my b term, or my d term, my d answer choice. This one, though, is the minus plus equation here. So notice if I square root my a term, this x squared, remember there's a 1 in front, becomes the square root of 1x squared. I'll write it down. So a squared equals 1x squared. If I square root a squared, that gets me a. And if I square root 1, that gets me 1. And square root x squared, that gets me x. And then the same with my b term. My b term is b squared equals 25. If I square root both of these, I get b equals 5. And so now I'm going to plug in. We need to know that my negative 10x, does that equal my negative 2ab? And so I'm going to flip this around here because that's how I've done the other problems. So my a is 1x, my b is 5. Does that equal negative 10x? Well, negative 2 times 1 is negative 2. Negative 2 times 5 is negative 10. And between these three values here, we end up with 1x. And that does check out. So that means that D is for sure the right answer. So A and D are the right answers. I'm now going to do the difference of squares. And I'm going to focus just on A and, 29A and 30. We can do B later on. I don't think you're going to see a problem as challenging as B on the test. So I'm going to focus on just 29A and 30. And if I have time, maybe I'll do B. So when it comes to these two, these are difference of squares problems. And luckily, there's only one equation for difference of squares. It's this a squared minus b squared equals a minus b times a plus b. And so on here, I'm going to write down that equation. So this is difference of squares. It's a squared minus b squared equals a minus b times a plus b. And this is going to be used properly. We're going to use the right side of the equations here. Unlike on the perfect square problems, we didn't really need the right side of those equations. So right here, what we have here is I can set a squared minus 16 equal to a squared minus b squared. This is also dealing with perfect squares. So notice 16 is a perfect squared. The number in front of the x squared here is a 1. 1 is also a perfect square. So if I go back to these examples, we have 1 and 16. So these are perfect squares. And when they say difference, they mean subtracting. And we're subtracting different squares here, perfect squares. So on this one, this is my a squared minus my b squared. And they want me to factor it down to an a minus b and an a plus b. And again, we should see the lesson on Thursday first before you do this, or you can watch the videos on Canvas. The idea here is I can square root my first term and my last term, and it'll immediately give me the factors of this kind of binomial. So the idea here is my a squared is equal to 1x squared, and my b squared is equal to this 16. We're going to leave that negative in as is. I don't care about that negative right now. So if I square root my a squared, I get a. If I square root 1, I get 1. If I square root the x squared, I get x. And I don't really need this 1 in front. So I can assume my a value is just x. So everywhere I see an a, I'm going to put in an x for a. And then if I square root my b squared, I get b. Square root 16, I get 4. And so everywhere I see a b, I'm going to put a 4. And then one of these factors automatically has a negative, one of them has a positive, and now I've factored this equation. So the idea is, for difference of squares, if you're missing that middle term always has an x in it. If you notice these are perfect squares, if you square root the first term and the last term, those are going to be what your a and b is in this equation. It's like a little shortcut. And so I'll do 30 here real quickly to kind of explain this one more time. The rectangular room number sign on Miranda's classroom door covers an area of 100 m squared minus 121 square units. What are the dimensions of the sign? So if we have a rectangle, let's just say we have like a length and a width. They want to know what are the dimensions of this rectangle. And they're telling me the area of this whole thing, the area equals 100 m squared minus 121. So notice 100 is a perfect square. If you square root 100, we get 10. If I square root 121, it's also a perfect square. It's 11. Now, I feel sorry for some of you because we haven't really talked about these kinds of problems at all at this time of year. We haven't talked about perfect squares, but we just kind of don't have the time to talk about it. So what I'm going to do is I'm going to write down this original equation, 100 m squared minus 121, and I'm going to match the original equation we have for difference of squares. We have a squared minus b squared equals a minus b times a plus b. And this is going to be a problem that's very similar to 29a. So what I'm going to do is I'm going to put a minus sign and a plus sign in these parentheses. And we're going to figure out what the square root of a is, and I'm going to write down that value in the front. I'm going to find out what b is, and that's going to give me what my b values are. So again, 100 is a perfect square. So if I were to set a squared equal to 100 m squared, if I square root a, that gets me, if I square root a squared, that gets me a. If I square root 100, that gets me 10. If I square root m squared, that gets me m. So my a value is just 10m. I'm going to put 10m here. And I'm really out of space here. I apologize for that. So that should be 10m. Let me kind of fix this a little bit. Still going to put a negative sign in there, but I put it in the wrong spot. And then I can do the same thing for this 121. If I have my b squared equals 121, I square root my b squared, I get b. Square root 121, you get 11. So my b value is 11, and everywhere I see a b in this equation, I'm going to put an 11. And this is my answer right there. So I'll highlight it. It's what those two binomials are, just like we did on 29a. And I'm not going to worry about b here. If we have time in class, we can talk about it. But again, make sure that you watch the video on Canvas going over this, on difference of squares and perfect squares. That's lesson 6-8 in Canvas. And then if you're in class on Thursday, this will make a lot more sense to you. But this is a long video. I'm going to stop this here. Hopefully this helps you out. Thank you very much. Bye-bye.